Next educational video. Let me show you two examples on locating and testing the nature of local extrema. Let's recall what we learned in the introductory video. The method is to solve this pair of equations for both local maximum and local minimum. We also learned that any point satisfying these equations is called a critical point. A critical point can either be a local max, a local min, or neither. And there's a derivative test to determine the nature of a critical point. Let's look at the first example. The first thing to do is to find the first order partial derivatives and set both of them to 0. Solving them will give us the critical point. For this particular example, there's only one critical point. X equals to 2, y equals to 6. I leave the computations to you. So far the conclusion is the function has exactly one critical point. Let's test the nature of the point to find out whether it's a local max, local min, or a saddle point. So we're going to perform this derivative test. In order to do so, we have to find the second order derivatives. So that can be done quite easily. We differentiate fx and fy with respect to xy. For this particular example, all the second order derivatives are constants. Most of the time they are not. But they are constants because fx, fy are linear functions. The quantities highlighted in red are those we need to draw a conclusion. It turns out that fxx is positive and d is positive as well. This combination leads to the conclusion that f has a local minimum at this point. And we are done. Example 2. This example to show you that a function can have more than one critical point. But first let's solve the equations we need to solve. The two equations in the box arising from gx, gy both equal to 0. Looking at these equations, obviously it's easier to work with equation 2 first, because equation 2 enables us to draw this conclusion immediately. When x times y is 0, then either x is 0 or y is 0. We will deal with these two cases separately. For the case when x equals to 0, equation 1 will lead to y squared equals to 1, which means y is either 1 or minus 1. So for this case when x is 0, we have two critical points, 0, 1 or 0, minus 1. The same for y equals to 0. Substituting this into equation 1, you have x equals to 1 or minus 1. So we have two more critical points, x equals to 1, y equals to 0, or x equals to minus 1, y equals to 0. So in total we have 4 critical points. And we're going to perform this test to determine the nature of each of them. Let's do this in an organized manner. Here's just a suggestion how we can present our answers. We draw a table listing down the critical points as well as all the ingredients that we need. In this case, the second order derivatives as well as this important quantity d. And finally, one column for the conclusion. Let's find the second order derivatives as well as the quantity d, and we substitute the values of x and y for each of these 4 critical points. Again, I highlight the quantities in red that we need to draw a conclusion. So we are done. It turns out that there are 2 saddle points, one local max and one local min.